Yay, congratulations. You just derived one of the two major operations or fundamental operations in calculus, which is the derivative. The derivative is actually the slope of the tangent line of any given function at any given point. As a matter of fact, you can find the derivative thing. It doesn't even have to be a function, but what we're going to be dealing with is functions so far. So our definition of a derivative is the limit as x approaches 0 of f of x plus delta x minus f of x over delta x. And in terms of the notation, the most common one is listed in the definition right there. Let me just highlight it for you right here. But there are lots of different notations for it. So for example, let me move this one up here a little bit. One of the most common ones is f prime of x, and you say it is called f prime of x. That's how you read it, and it produces a new function. It's not the same function, it is a new function in and of itself. Another common way is the differential called dy dx. You write dy over dx. D stands for delta essentially, but I have applied a limit to it. So instead of writing delta, now we're writing the letter D, which indicates that a limit has been applied. And here we write dy dx. That's how it reads. So when I say dy dx, it means dy over dx. Another common one is just y prime, like that. There's a couple other ones, d dx of f of x. That means take the derivative with respect to x of the function f of x. Another one that's fairly common is capital D and then f of x as well. That means take the derivative of f of x. And sometimes I've seen this, not as common though. And if we come across new ones, we can add to it. So our job then is to try some of the examples. So now it's an example 3. Let's see if I can zoom it a little bit. Ooh, I'm not very good with the, oh, here we go. Much better, like that. So if I zoom in on just A, it says find the derivative of f of x is equal to x to the third minus 3x. Use the definition of a derivative as shown. So I know some of you guys have been taking physics and you have the derivative rules, but if it specifically asks you to use the definition of derivative, you have to use the limit. So there's no way around it, and you need to practice this. The first quiz you're going to have is, I'm going to ask you to do this. So we're going to write f prime of x is equal to the limit as delta x approaches 0. You could also use the letter h instead of delta x. It's just a preference thing. Over, then we have to, wherever we see, and some people like writing, for example, because it gets messy really quickly, they like writing f of, I know I have to find x plus delta x, and I have to, f of x is already given, so I don't have to find that one. We're not substituting anything in. So I'm going to write, it's going to be x plus delta x cubed minus 3 times x plus delta x. That whole thing, that's this one down here. Wherever I see that, I have x plus delta x cubed minus 3x times delta x. Ooh, that looks funny. Let me fix that for a minute. I don't know why it's doing that. X plus delta x, like that. It did it again. Here we are. Delta x, like that. So that's what I'm putting in for all of this whole mess here. That's f of x plus delta x. And then we have to do minus f of x, which is x cubed minus 2, not 2x, 3x here. Let's fix that. 3x. So, like that, all over delta x. Now, to expand that in the numerator, so just to clarify, this here is the f of x, like that. So to expand that, it might behoove you to write it separately because I have to expand x plus delta x cubed. That's a binomial expansion, or you could take x plus delta x squared and expand then that and then multiply again by x plus delta x. It becomes x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. That is just this expansion right here. That corresponds to this. And then minus 3x plus 3 delta x. And that would be, sorry, that's my little dog complaining. Here, that's that part here. So to highlight. And then I'm just going to simplify a little bit. I don't think I have any like terms at all. So I'm just going to leave it as it is. So then we're back to the limit. So look, I have a bunch of work in the middle. I don't want to write an equal sign and have it be confused with it being equal to f of x plus delta x. So I'm going to restate f prime of x. This is really important. You can't willy-nilly have equal signs and then change what you're doing and then just keep writing equals as if it was equal to what you just wrote if you mean that it's equal to the stuff that was before it. So we're going to write f prime of x again, the limit as delta x approaches 0. And then this entire expansion needs to be there. So I'm going to have to write a little bit slow, or a little bit small, I mean. And then here plus 3x squared delta x plus 3x delta x squared plus delta x cubed minus 3x plus 3x. No, that's not an x on there. That's a delta x. Plus 3 delta x minus x cubed minus becomes a negative because we distribute the negative, it becomes a 3x, like that, all over delta x. So now I'm going to go in and cancel. And by the way, this part here that I'm underlining in green corresponds to this part up here from the original. That's I underlined in green there. And I'm going to go in and cancel out. I know that this one cancels with that one. Those are like terms, but they have opposite signs. And there's also a negative 3x and a positive 3x. Right now, every single term in the numerator has a delta x in it. That means we can factor it out. So let's do that. Because if I tried substituting in delta x is equal to 0, it would get indeterminate form. So sorry about my handwriting, but I'm trying here. F prime of x is equal to the limit as delta x approaches 0. And then we're going to factor out the delta x. And it's going to give me a 3x squared plus 3x